everyone, and welcome to CoMotion Labs. My name is Suni, and I'm the manager of this floor. CoMotion Labs is a multi-industry incubator hosting high-tech startups both inside and outside the University of Washington. Our 3 buildings are all located in the greater University District area, and we host 3 different disciplines of startups. In the back, we have 24 different companies that are working on solutions for augmented reality and virtual reality. In our other building, Startup Hall, that's home to our IT and software companies, as well as Bunker Labs, and as well as the Techstars cohort. And over in Fluke Hall, that building hosts engineering, life sciences, and medical startups, as well as our Makerspace, which has just become open to the public. I'm pleased to welcome you all to the first event in our 5-part blockchain basics series. Yay! Our goal for this series is to provide sessions that are meant to approach technology in a very accessible way for newcomers. Please note that our next event is next Tuesday, that's 3/20, and that's titled Assets or Currency, Speculation or Investments, the Implications of Bitcoin Investment. The speakers for that event are going to be Lawrence Lee, Rahul Sood, and Amy Eskridge. Many thanks to one of our collaborators, the Seattle Angel Conference, for working with on this event, as well as the Seattle Angel Fund and the Seattle Entrepreneurs Club. And I'm going to give the Seattle Angel Fund a couple of seconds to have a couple of words.
Cool. Thank you. Hi, I'm John Seacrest. I run the Seattle Angel Conference. The follow-on program for us is the Seattle Angel Fund that Sue Preston runs. Our goal is to help companies and investors get together and make progress. So we work for companies that are brand new, near revenue, try to get them accelerated, and try to produce new angel investors. So in this process of blockchain, and then blockchain becomes a business, we're interested in trying to help that go. So we would ask you to talk to people about how they're going to monetize their blockchain process. I also run the open coffee every Tuesday morning at Galvanize. So if you would like to chat about this, that's a good place.
And then the Seattle Entrepreneurs Club.
Hello, everyone. My name is Man, and I'm from Seattle Entrepreneurship Club. And we are hosting a startup weekend in early May. And it's a weekend hackathon on blockchain theme. So I have a bunch of cards at the elevator. You're welcome to grab one. So, yeah, thank you.
And then, is there anyone here from the Seattle Angel Fund?
I don't think I saw Susan, but I'm glad to chat about it for a second if you want to know.
Sure, that's fine.
So Seattle Angel Fund is one of the programs. There are 11 angel groups in the area. There will be on April 18th a Meet the Angels workshop by the MIT Forum in Kirkland. And Seattle Angel Fund fits into there. So Seattle Angel Conference is the beginning. Seattle Angel Fund is sort of the next step. And then there's Alliance of Angels and Kretsu sort of at the top. So if you want to know that journey, or if you as an investor, accredited person, want to know how to get into that, we'd be glad to introduce you to Sue Preston at the Angel Fund.
I'm thrilled to introduce our 4 experts on blockchain for the day. We have David, is it Zhang? Cool, and then Chris Robison, Paul Handy, and Alex Renz.
Cool, thank you guys so much for having us. Again, I'm Chris, and this is David. The topic of this conversation is going to be an introduction into blockchain. So we're going to give an overview of the different aspects of it, the technology, some of the economic incentives. There's a lot of nuance to blockchain, so if we say anything up here and you need some clarification on a certain aspect of that, feel free to raise your hand. Questions, however, we'd like to save until the end. So if we could move forward in that regard, that would be really helpful. Yeah, so the first thing we're going to talk about is really what is the problem that blockchain solves. So you'll hear people frequently talk about blockchain being the greatest invention since the internet. So let's unpack that a little bit. What does that actually mean? So the internet really solved the problem of mass communication for the first time. So although we were able to communicate, we weren't able to do it in a large distributed way. For the first time with the internet, we were able to start sharing web pages We were able to build websites. Now we have full platforms for communication. We have social media platforms. So now everyone is able to communicate in this massively distributed way. And this sort of builds up to what blockchain provides us with, which is a solution for actually creating consensus once we are able to communicate around a single objective. So in computer science, this is referred to as the Byzantine generals problem. There's a lot of ways to break down what this story actually means, what this problem is, but the basic concept is that there's a general and he has a number of armies. He's able to communicate with them, and he needs all of them to move in on a castle at the same time as a plan of attack. He needs to make sure that everybody works in coordination to achieve that objective. If anybody decides to back out at the last minute, or if communication is misconstrued in some way, then they would fail. They need everybody to move together as one to achieve this objective. So the first application that we're looking at with blockchain, the first objective that's looking to be solved, is money. So I'm going to have David speak about that.
Right, so how do we solve this mass cooperation problem? So this is where Bitcoin really came into the scene. So people refer to Bitcoin as the first successful blockchain application, and I'll get into what that means in a moment. But basically, the problem that Bitcoin solved was the mass cooperative problem of transferring Bitcoins. So it sounds a little circular, but we'll dig into the pieces in a moment. So Bitcoin is basically just a network, which is just a series of computers whose sole purpose is to move Bitcoins from one place to another. And the way that Bitcoin solves this problem of mass cooperation and making sure that everyone moves Bitcoins in the same way really comes down to the blockchain technology, which really comes into two parts. So blockchain, when usually people talk about blockchain, they're actually referring to the data structure. And all a data structure is, it's a way of organizing data in a certain way so that it's easier to use. And then the other part of blockchain is really the network itself. So if you only have one computer running a blockchain network, it's not really much of a network. So in order to get all these computers to work together, you need what's called a consensus mechanism or a consensus algorithm. And it's really these two components that combine to form the underlying technology of public blockchain networks, also sometimes known as distributed ledger systems. But public blockchain networks aren't really the only kind of blockchain network. So let's take a quick look at what the other kinds of blockchain networks could be.
Cool. So David talked about the fact that there are public networks that exist in the ecospace. We're talking currently about Bitcoin being the first one and maybe the most widely adopted at this point in time. So it's a public chain in the sense that this distributed ledger can be accessed by anybody. It's open, it's transparent, so anyone in this room could go ahead and take a look at the transactions that are occurring on this network and verify that ownership is being transferred from one individual to another. It's also open and unpermissioned, and that means that everyone here can actually not only look at the information, but they can participate in the network. So you all could transfer value from one person to another directly in a peer-to-peer way without an intermediary stepping in as a trusted resource. In the same vein that there are open networks that are unpermissioned, that are public, there are also private networks. So for example, we also have Monero, which allows you to transfer value across this blockchain in a peer-to-peer way, but you're able to encrypt that information so that way you can keep the information private. So for example, if I were to send some Monero to David, we could do that in an encrypted manner where only he and I would be privy to the amount that we were transacting. None of you guys would be able to see what that was, but you'd all be able to verify that a transaction did in fact occur. There are also variations of blockchain out there that are closed and permissioned, and what this means is you would have to have access to participate in this network. So IBM has a project out there, it's called Hyperledger, and this is intended mostly for enterprise solutions. So it's a closed system that's intended for something like an intranet for an organization. Maybe they have a number of branches and they all need to coordinate around some sort of objective. They'd be able to do it internally, but for example, a company would not want that information open to the public network because it might contain some private and sensitive information. There is also another variation of permission ledgers which still uses public networks, so you can verify that transactions are occurring This is also used for enterprise solutions. JP Morgan came up with a product called Quorum, and this does exactly that. Again, for most of what we're talking about today, it's going to be referring to public and unpermissioned ledgers, so ledgers that all of us can use here, but just we wanted to make sure that you guys were aware that there are different variations of them out there.
Okay, so let's dive a little deeper into what this blockchain data structure actually is. So first, why is it called a blockchain? So it's called a blockchain because it's a series of time-stamped blocks, and then, if you look at them over time, it sort of looks like a chain. So now you're probably wondering, okay, what are these blocks? So first, I'm going to talk to you about transactions. So on the Bitcoin network, for example, a transaction is simply me telling the network, person 1 wants to send X amount of Bitcoins to person 2. And then there's tons of these transactions going into the network, and the network participants basically verify these transactions and bundle them together and put them into what is called a block. So the mechanism for generating the block is part of the consensus algorithm, which we'll talk about next. But basically, each block is simply just a bundle of transactions. And by going through all the history of all the blocks over time, you can basically see everything that's happened from the beginning up until now. And anyone can verify this as long as they download the whole blockchain.
Yep. So again, we're talking about these computers across this network that are keeping track of all the transactions that are occurring. And there has to be an incentive for these computers to actually go ahead and do this work to make sure that they're keeping track of who has what Bitcoin and when. And so that requires a consensus mechanism. So there has to be incentives involved for people to commit their computers to doing this work. So there's two main variations of a consensus mechanism out there that are currently widely adopted. The first one is proof of work, and the second one is proof of stake. So we're going to unpack each of those. Bitcoin uses proof of work, and so we're going to dive into that one first. So proof of work is a very robust mechanism where anybody in the system is going to take their computer and they're going to commit hashing power to the network. So what they're doing is they're taking a certain software and installing it on their computer to hash away at a difficult problem, and they're competing with all the other computers in the network. So the first person who solves this difficult problem is the one who gets to go in and click the save button when that block is added to the network. So they're going through and there's a list of transactions, and if they solve the problem, then they get to be the ones who go in and hit save. So that confirms that those transactions are valid across the network, so everyone can trust that those set of transactions actually occurred. So let's see. I guess, yeah. So the incentive for doing this, for actually going in, and why everyone wants to go in and make sure that these transactions are actually occurring, is because they're going to get rewarded for this work. So that comes in two different parts. The first part is new Bitcoin is issued for each one of these new blocks. There's only 21 million Bitcoins that are ever in existence. There has to be a way to distribute these evenly across the network. So for each person who solves one of these blocks and is the one who clicks save, they get some of these new Bitcoin issued to their account. They also get all the transaction fees for everybody who transacted in that block leading up to that time. So there's a monetary incentive for that action to take place. The other mechanism that exists is proof of stake, and there's no computationally intensive work being done here. Instead, what happens is people take a certain amount of their tokens and they put them into a pool, and the number of tokens that they put into that pool entitles them to a certain probability that they're going to be the ones that get to go in and click save at that block checkpoint. So for example, if there were 100 tokens put into this consensus pool and you put in 10 of those tokens, you have a 1 in 10 chance of being the one to click save on that block. You will also have the 1 in 10 chance of then getting the block rewards and also collecting the transaction fees.
Okay, so hopefully you have a little bit of an idea of how the two components work together. So the data structure and the consensus algorithm. So basically, at some point, people realized, hey, wait a minute. So Bitcoin has this unique data structure and this unique consensus algorithm, but how can we tweak things to create all sorts of different applications that do more than simply move Bitcoin from one person to another? And so basically came all of these hundreds of thousands of projects, and some of them are still alive today, and we're going to talk about a few of them in particular.
Right, so there are different ways to pair the consensus mechanism with the data structures. And some of those projects are very interesting. The first one we'll talk about is Filecoin. So we talked about all these computers across the network in the proof of work system, just committing hashing power to solving these mathematical equations. A lot of criticism about this mechanism is that it wastes a lot of energy. All they're doing is computing this Bitcoin algorithm over and over and over again. What Filecoin does is something very interesting. It takes that potential and converts it into a different resource, which is file storage. So now anybody here could open up their computer, and if you have extra storage on your computer, you could go ahead and rent it out to the network. So somebody else could come along, and if they have a bunch of files that they need stored in a distributed way, then they could go in and submit it to the network, pay a certain token, and you could earn a percentage of revenue for the work that you're doing in storing those files. Another project that exists is also very similar. It's called Golem, and they also take advantage of that proof of work model. They generalize what the work is that's actually being done, so it creates this two-sided marketplace where still you can take the extra computation power that your computer has and you can submit it to a network, but the work it's actually doing is, again, not just a single algorithm over and over again like in the Bitcoin network. It can be generalized for any problem. So your computer, while you're away at work, if you have a gaming computer, for example, you could be hashing away at a large data set for a university who's doing some research. There's a widely adopted project out there called Folding Coin, which involves computing protein folding over and over again, so it actually has a public good, public benefit, and you receive tokens for that. But developers can submit any sort of program to this network. They can create a microservice and have it computed in the Golem network. One use case that is very popular is perhaps with architecture students who are in school. They can't afford a high-end computer, but they still need to render their 3D graphics. They could go ahead and use the Golem network to make those computations for them, and then they'd be able to receive those files later and pay the processing power in this Golem token.
So we've seen a few examples of how you can apply different data structures and consensus mechanisms to create different applications. So then someone had the bright idea, hey, wait a minute, what if we generalize this even further, and what if we just make a general blockchain platform for doing any sort of computation? So that's really where Ethereum comes into all of this. So the general idea behind Ethereum is that instead of each transaction being for some specific purpose, like in the example of Bitcoin, transferring Bitcoin from one person to another, instead, what if we just make transactions just arbitrary code execution? So what the Ethereum network basically allows you to do is it allows you to run code on this Ethereum network, and everyone verifies that the code produces some output, and this is the transactions that are getting verified. So there's a term that you might have heard thrown around called smart contracts. All a smart contract is, it's just a collection of code that lives on the blockchain. So as an example of a simple but more complex transaction than you might be able to do on some other networks is, so let's say I want to create a ticketing platform, but I don't want it to be hosted by like one central party. I don't want like, secondary markets to form around it where they go and buy and sell this without permission. So I decide to create a ticketing platform on Ethereum. So what I can do is I can link my event tickets to a specific account, and then I can prevent stuff like, people double selling tickets, which I'm sure some people here might have experienced, where you buy a ticket from a secondary market and it turns out that it's not a valid ticket. Or you can, directly sell tickets from one person to another in a publicly verifiable way. Other applications include like escrow, for example. Let's say instead of hiring an escrow company to lock up my funds until some conditions are met, I can instead just write a smart contract which says if these conditions are met, then release this money to this person. Otherwise, by some deadline, send it back to me or something. So basically, anything that you can really code up, you can create on the Ethereum network. The language is what is referred to as Turing complete, meaning that any solvable problem can be, or that you can type up, you can solve on this network using this language. So this sounds like a lot of magic, but there are a lot of caveats. For example, computation is very expensive on this network, so you wouldn't want to do something like protein folding. Storage is also very expensive on this network, so you wouldn't want to do something like storing files. But that being said, if you want to do something that requires, certain logic to be followed, and you don't want anyone to be able to censor that sort of logic, or you want it to be done in a publicly verifiable way, Ethereum might be a good platform to use. So that's just a very high-level overview of what kinds of different projects are currently out there. But we talked a lot about blockchain today, but that's actually not the only type of distributed ledger protocol out there. So Alex will be coming up to talk about another project, IOTA.
Thank you much. Thank you much. Great job, guys. This is a very complex topic, right? So don't really expect to understand everything if this is your first exposure to blockchain technologies. So as David says, there are blockchains, but really the more general term is distributed ledger technologies. So a distributed ledger as a distributed database, very generally speaking, right, could be implemented using a blockchain, but can also be implemented in other ways. And I'm here to talk about IOTA, which is the first implementation of a distributed ledger using a directed acyclic graph. So what I want to talk about is what is IOTA and how is it different from blockchains, and then also some use cases, because I think you will see that there's a lot of different blockchain technologies to address many different use cases, and one is a better fit for one versus the other. And then we will open up for some Q&A. So as we heard, right, the blockchain is basically a model where you separate the transaction from the consensus process, right? So every 8 minutes, you calculate a new block. And therefore, of course, it is asynchronous. The challenge now is, of course, that if you want to post a transaction, you need to make sure that you are getting into that next block, yeah? So you're basically competing with other transactions for getting into the block. And as we heard, there are miners that basically are responsible for that consensus process, and their incentives are mining fees, right? So what you introduce now is basically transaction fees, yeah? And those can become very substantial depending on the status of the network. So as all these different transactions are competing to get into the next block, there can also be unposted transactions. So there's like a backlog in the blockchain, right? And depending on your business application, that can be a problem, right? So the other thing, of course, is that when you have miners, then you are dealing also with big mining farms now, right? It started all very small. People started to mine Bitcoin and so forth, right? But now really we're dealing with high-end GPUs and really mining farms, which are in many ways, clouds that are now competing to make a business out of mining, right? So there's some level of centralization in that network, yeah? So the founders of IOTA have been part of the initial, blockchain 2.0 movement, as these guys talked about, the blockchain 2.0 like Ethereum and so on, and they always saw some of these challenges coming back again and again. So they came up with a different approach based on this directed acyclic graph. So think about this as a network, a unidirectional network, a graph, yeah? Where now things work very differently, right? In this network, you don't have a decoupling of the transaction from the consensus process. But if you want to post a transaction on this network, and posting a transaction cannot only mean monetary transfer, but also sharing data, for example, on that network, then you need to validate 2 other transactions. So basically, you as a network participant now are also doing the mining, if you wish, the proof of work, the validation of other transactions. The cool thing about that is it has a bunch of different benefits. One of them is it scales very well. Where blockchain has the scaling issue, in IOTA, since as you validate a transaction as a node, you validate 2 other transactions, right? It scales very well. And the more activity there is on the network, the better the whole model scales, right? So the notion is, of course, that this model will become infinitely scalable, especially when you consider that this is a very lightweight protocol, so you can run it on low-end computing devices. Yeah? The other cool thing here is, and especially when you think about the Internet of Things, for example, and the machine-to-machine economy, you want to figure out, if you then introduce a transaction fee of, let's say, $15 or sometimes more, yeah? That's not only a challenge in traditional like banking and monetary transfers, but especially when you think about an Internet of Things where individual things want to collaborate and be paid for providing services to each other, of course, that would be unfeasible. Yeah? So the cool thing now, because you don't have any miners in this model, is that you basically can do feeless transactions. Yeah? So you can really truly transmit very, very small amounts of money without having to incur any transaction fees. So the vision of the IOTA founders is now that as we see the Internet of Things explode, yeah, that there will be a machine-to-machine economy ultimately where these things pay for each other, pay each other for data and so on. And they think of IOTA as this new backbone for this machine-to-machine economy. One other important aspect is, we all have, there's a lot of IoT activity out there, right? But there are many very fundamental issues of security, cybersecurity are unaddressed, yeah? So how do you know, let's say when you think about a platooning scenario for trucks, right, where these trucks form like a train of trucks, right? How does that one truck really know that the other thing is a truck rather than some fake ID, right? How do you know that your smart home devices really are the things that they pretend to do? So with IOTA, we can establish these trusted identities and establish this trusted connectivity between things, yeah? But not only for things, but also for people, right? We need an identity. You all remember these cartoons with the dog that says, on the internet, you can be anybody or anything, right? And today, the best thing we have is something like Facebook ID, right? But we think that nobody should own and control an identity, especially when we think about data being the oil of the future economy, right? It's important that we own our identities and that we own the data that we generate, so we have control over it and can figure out, what happens with the data as well. The other thing, as we heard, right, one key aspect of distributed ledgers is, of course, that there is like a single version of the truth, that there is an immutable ledger that is shared across different participants. Yeah? So with IOTA, you can create that immutable ledger. Nobody can change data after the fact. Yeah? And when you think about like an Internet of Things and things sharing data, not only can you ensure that we can trust these different things to be what they claim to be, but also as you transfer data, we can ensure the data integrity. So I work a lot on mobility, for example, autonomous connected vehicles and so on, right? So when you think about it, in the future we will have machine learning models that will be generated typically in the cloud, yeah? And then they have to be downloaded to individual vehicles as part of the in-vehicle AI to basically make decisions based on the sensor data the vehicle collects. Yeah? And where it stands, the OEMs will then be responsible for making sure that these things are safe. Yeah? So imagine you as an OEM want to use over-the-air updates to download these machine learning models into your vehicles. You want to make sure that there is data integrity, right? That model arrives exactly the same way that you have generated in the cloud, and that there are no man-in-the-middle attacks. Yeah? The other thing, which is really mind-boggling in many ways, if you think about it, yeah? I come from the world of enterprise resource planning. I worked for SAP and Microsoft and so on. Yeah? And we have this mindset in those days of this four-wall enterprise where we use an accounting system, an ERP system to do accounting and do financial transactions and monitor inventory. Yeah? But when you think about it, a lot of our business, of course, is really a multi-entity network. And in the future, we see these distributed value networks. When you think about the convergence of energy, communication, mobility, right? We move towards electric mobility that we generate using our solar rooftops, yeah? We might want to trade energy peer-to-peer, yeah? We power our electric charging stations with it, yeah? The car is not only consuming electricity, but it's also storing energy and can feed it back into the grid when we need to, right? And to bring all of that together, of course, we need data communication, yeah? So imagine now how we can really start to think about automating a lot of these processes using a distributed ledger. So there's huge potential for increasing productivity. So when you think about this, the vision for IOTA is really to become this backbone of IoT and this machine-to-machine economy. Yeah? Everything becomes connected. I think there's a lot of potential in that, but I think also we need to make sure that it is safe and secure, yeah? That we, as the people, stay in control, that we can own this data, control what happens with that data. And then, of course, also as you think about all of these things, sharing data, generating data, the question is in the future, who will own the data? Today, there's a few companies in the world that own a lot of the data. And the internet has become pretty much centralized, yeah? And there's a lot of danger to that. I think we all see that, and fake news and everything else. So it's very important, I think, for the future of the world, for our futures, that we make sure we can all benefit from this digital transformation, right? And such a distributed ledger where we have these identities and we can be in control of how we share this data. This thing has the potential to become the biggest source of trusted, validated data for machine learning and AI, right? And as we move towards distributed AI, there's huge potential really in this technology. So, when we think about a smart city and everything that goes along with it, the mobility, the energy, infrastructure, all of our mobile devices, all the sensors all around us, yeah? These are all part of this mesh network that is the Tangle, yeah? And, these all share data constantly and update the Tangle and validate data, and it becomes almost like a living system that, however, is highly decentralized and nobody's in control. There's a lot of work going on around this. So, for example, this is a picture from the signing with the Taipei Municipality. There's work going on to make Taipei a smart city using IOTA and also to explore e-citizen cards where we have this digital identity on the ledger. There's a lot of work going on around electric mobility, not only with traditional charging, but also inductive charging, right? Imagine you have your car, you stop at a traffic light, and now you start to establish this trusted connectivity, right? Yes, I'm a charging station, I'm a car, yeah? Now they start to transact and stream energy in exchange for tokens in real time, right? So we do a lot of work in the mobility space, and these are just some of the use cases, over-the-air updates that I mentioned. But also think about, in the future, you may have a shared vehicle. So we may less and less own a vehicle. Another question is not only how do we model shared ownership models, but also how do we monetize features on demand. Today, the OEM selling you your infotainment system, when you go into the store and they promise you it will speak to you and do voice control and everything, yeah? And once you are driven off the lot, nobody cares, okay? So in the future, we need to really monetize these features on demand, right? So if I can sense that you are cold, I may want to sell you the feature of heated seats, yeah? And I do microtransactions, for example, to monetize that feature across the life cycle of the vehicle, yeah? Of course, there's also a lot of stuff going on around connected, V2V, V2X, yeah? Platooning, as I mentioned. But also think about, how we actually think about maintaining our infrastructure. So we have a lot of discussions with departments of transportation, right, who understand that there is value in data to better maintain the infrastructure, but they also have a privacy concern, yeah? So when I tell them, hey, with IOTA, you can collect data from these vehicles without having to disclose the identity of that vehicle, yeah? But you get the data to know where the potholes are, yeah? And then you can even incentivize people for sharing that data using microtransactions or for free services, yeah? But even better, you can actually start to monetize the use of the infrastructure in real time, yeah? The fuel charges will go away over time as we move more towards electric mobility, right? So how do we pay for maintaining the road infrastructure? So especially when we think about robotic taxis driving around, they may just pay as they go for using the infrastructure. So the Department of Transportation may collect in real time tax revenues. Yeah? Then, of course, you can also think about stuff like usage-based insurance and so on. But when we think about these kind of things like insurance, it's also very important that we maintain the privacy and think hard about, do we want a risk pool of one, and how do we apply this technology to make better decisions around insurance and better assess risk, but at the same time make sure that we maintain a privacy as we should. The other thing is the sharing economy. Yeah? I mean, and I call it the true sharing economy, because today when we talk about the sharing economy, we basically have some centralized players that essentially extract value because they don't own any vehicle, or some people, they don't write an article, or they, right? So media journalists are kind of in a difficult position because it's the big platforms that monetize the content, yeah? And likewise, when you think about shared mobility today, it's pretty hard to make a living that I think is a decent living, right? But I think there's huge potential because today we buy a lot of stuff that really is not getting used very often, right? And I think with our state of the world, we need to move to a model where we don't just build stuff that's not getting used, but we need to be smart about actually utilizing the assets, yeah? And with distributed ledger technologies now, you can really model shared ownership models, yeah? Imagine a household, or let's say an apartment building that shares a vehicle, right? I can model the shared ownership, and I can then actually also figure out like how many miles did you actually drive, and we can sort it out so it's a fair thing, yeah? And we can do that now without any central intermediaries, right? So imagine like a distributed ledger-based car sharing or ride-hailing system, yeah? I always say when I go to the airport, rather than calling my favorite ride-hailing service, I should be able to discover locally in West Seattle, where I live, where there's somebody else that wants to go to the airport today, yeah? And because we use these trusted identities, right, I don't need to know that person, but I need to be sure that it's not a criminal, that there's some level of reputation there, yeah? And we can figure out, you know, what should be the compensation if I take my car and take this other person along, yeah? So disintermediating a lot of these platforms and really making sure that we have this distributed economy is really a powerful thought, yeah? And likewise, when you think about energy and so on, yeah, I mean, you know, we all are more and more increasingly like prosumers of energy, where we generate energy, but also then sell it back into the grid, yeah? What if we could trade this energy peer-to-peer, yeah? So we don't have to store it, yeah? So there's a lot of potential, I think, in really thinking about this true sharing economy. So this is one of the strategic partners of IOTA, Volkswagen. So this guy is JJ Jungwirth on the left. He used to be at Daimler, and then he went to Apple to work on the Apple car, and now he's the chief digital officer at Volkswagen. And you see him sit there in the Cedric, which is the robotic taxi project of Volkswagen, together with Dominik Schiener, one of the co-founders of IOTA. And you know, there's a lot of work going on. JJ is now in the supervisory board of the IOTA Foundation. And when you think about it, and I'm just talking now in general about the use cases of IOTA in the context of robotic vehicles, yeah? I mean, just imagine you basically just call one of these vehicles and they are now their own economic agents, right? They basically are no longer, they have their own ledger, right? They buy and sell stuff, they generate their own revenues, yeah? But also thinking about identities, you know, when you think about a shared mobility system like, you know, Moya and other mobility services that the OEMs, the original equipment manufacturers, are now working on, it's not just about having a car in the future, it's about multimodal mobility, right? How do you tie all of these different things together in a seamless way, yeah? Right? Going from a bike sharing to a car, shared vehicle, public transportation, and so on. There should be one single identity through which you can seamlessly access all of these services, yeah? And there's, by the way, also a benefit for the corporations, because, you know, when you think about all this data, when you want to get a shared vehicle, yeah? And maybe there's a car to go right around the corner, right? But you don't have an account because nobody has validated that you have a driver's license, you have not set up an account with that, yeah? And there's a Reach Now vehicle that is much further away, for example, right? Imagine if you had this identity and there would be attestation that, yes, you have a driver's license, you have proof of insurance, and you have a form of payment, ideally using IOTA attached to it, yeah? You should now be able to access any of these shared resources, yeah? In a seamless fashion. And actually, you also avoid creating honeypots of data that way, yeah? And more corporations realize that, especially in Europe with the new GDPR regulations, that it's also a liability to have control and ownership, if you wish, of that data, right? So if I can minimize the amount of data I need to hold, there's also less risk for me as a corporation. The other company that we work with very closely in the IOTA Foundation is Bosch. Yeah? So Bosch, you may know it as a household appliance, but Bosch is the biggest automotive supplier in the world. Yeah? They have more patents than anybody else on autonomous vehicles, for example, but they have many other business interests. Yeah? So they are working in buildings, smart cities, electric power tools, and so forth. Yeah? And the vision of the CEO is to become a product and services company, right? And to really leverage distributed ledger technologies to basically enrich these physical products with services and be able to monetize it, yeah? We talked a bit, I think, about this notion of autonomous economic agents, right? And when you think about modeling things, again, back from my ERP world where we modeled all these processes, you know, it's a radically new thinking if you start to really model from the bottom up, yeah? And think about all these things that carry a microprocessor having their own identity and becoming their own economic agents that, you know, share resources with other entities and generate revenues for it, yeah? So this car will look around for passengers or cargo and generate revenues. It will pay for its road usage. It will pay to the electric charging station. It may make some money selling data to third parties that generate services out of it, yeah? But it's really a self-interested economic agent. And you know, these things are really data collection machines at the end of the day, such a robotic taxi. Yeah? But everything around us now generates data. And the question is, how do we harness the value of that data without becoming enslaved, yeah? And without, you know, having, you know, 5 companies in the world not only own all that data, but owning 90% of the artificial intelligence that's generated from that data. So one thing that IOTA is active on is to really leverage data as this new oil, and has created a marketplace of data. Yeah? There are like over 50 participants in that project, where the notion is, you know, today it's pretty simple stuff. Like imagine you have like an air quality or temperature sensor somewhere at home, yeah? Or the city has a lot of sensors deployed across the city. Oftentimes there's very limited use of that data, right? It's all locked up in corporate silos, yeah? It's not really shared. And what we do with IOTA is to really open up this data, but at the same time allow everyone to maintain control and ownership of the data. Yeah? So you could decide who do you share this data with and exchange for what. Yeah? So you can essentially stream your air quality sensor data or your temperature sensor data, and you can monetize it. Yeah? And this is actually a project that is now opening up to the broader public. Yeah? So you can play around with it and publish your own data and so on. Yeah? But this is more like, you know, a proof of concept to enable third parties to build such marketplaces, right? Using IOTA technology. Here are some of the participants in this, and there's a lot of, you know, cities, businesses, universities, and so on involved. Yeah? A little bit about the IOTA Foundation. So IOTA is a foundation registered in Germany. And maybe from my West Seattle accent, you have maybe told by now that I might have something to do with Germany. It's the first of its kind in Germany. It's the first foundation, and there's very strict regulations that you have to you know, adhere to if you are a foundation in Germany. And it's the first one based on a cryptocurrency. So in summary, you know, IOTA is one technology to implement a distributed ledger. It's not based on a blockchain, but based on this directed acyclic graph, the Tangle, that is like this living mesh network of transactions that we all and our things can contribute to post-transactions to validate transactions in. And we see the future, you know, to be like this machine-to-machine economy where IOTA helps to establish that trust and enable these machines to become their own economic agents, transferring data, monetizing that data. And because there are no transaction fees, yeah, these things can now really collaborate to form larger services and make that economically feasible. Yeah? We see a future of a true sharing economy where we truly do peer-to-peer sharing of assets and help drive better utilization of these assets. And of course, a key aspect is to really figure out how can we share our identities and take back ownership and control of our data so we can all control and influence our future. Thank you very much, and I think we are now going to some Q&A. So I'd like to invite David and Chris up, and also Paul as my support. Paul is a core developer, as we call it in IOTA. So when you start to play with the Tangle, then I think you had a lot to do with that, right? In terms of building that core protocol. Yeah. So with that, I guess fire away.
Yeah, so everyone who has a question, if you don't mind just lining up over here, and then we'll have each person come up. We have one microphone today. We actually have two. Perfect. Okay. So whoever has a question first, perfect. You do this even here.
Thank you very much. It was a great talk. You mentioned about trusted identities and the importance of that. But how do you prevent people will have fake identities or hacking that identities? What will prevent people doing that? I still couldn't understand.
And we actually do have two microphones, so the other microphone's over there. So if you do have a question, please line up over here, and then I'll give the microphone back to you guys.
Cheers.
Thank you.
This is working, right? I think everyone can just hear me anyway. I don't actually have the answers for that specifically because I'm not currently working on the Identity of Things project. We have we actually have a work group of a number of people from a few industries and some experts on public key infrastructure that are working on that model right now. But one of the important things in that is that you have hardware-based encryption, and you would generally expect people to not have ready access to like some fancy X-ray spectrometers to go and look at the private key that's sitting on some device out there. When we're talking about Internet of Things, we're talking about devices that are built to go out and pretty much not change what they're doing. Which is why we're trying to, in IOTA, we're trying to actually really target the lowest common denominator. We're trying to be as efficient as possible, and I think the hacking of those things. Well, if someone has access to the device or whatever, I think that's where the reputation system comes in. But the overall ecosystem of that is something that I think is currently still a collaborative effort between a number of people, but it's something that we're working toward, and a number of the things that we're working on, like masked authenticated messaging, which is encrypted signed data that happens over the Tangle network, is a key aspect of that.
So like one way to describe it is, think about IOTA. If there are all these different devices that are part of this network, right? There's a transaction history, eh? So like if you want to know, hey, can I trust this person that I just met, right? Mm-hmm. You may ask your network, hey, what do you know about this person, right? And just think now in the world of IOTA, you ask 1,000 people, can I trust Paul, yeah? There'll be like 5 bad actors that say something wrong, yeah? But 995 will say he's a good guy, right? So that's a way to think about how you can establish trust through the network.
So my question kind of got deflated because I was going to ask if you guys were involved in self-sovereign identities and the standards around DIDs, distributed identities, and I probably could help answer some of your questions around that. But you said you aren't on the identity track, so.
Me personally, I'm on other projects.
Right.
There's a work group that's in on that, and
there's a first of all, IOTA is like a core protocol, right? And yes, there is a lot of work going on around identities for people with a lot of organizations, yeah. But we can't go into much detail about it.
Yeah, and that's one of the reasons I asked the question, because yours fills another niche with identities for people and organizations is what a lot of the work is being done on, and I don't know that there's anything done on. I don't know that there's anything being done on identity for IoT devices. So I was curious if you guys were using the same patterns.
It's targeted for IoT devices. It's targeted for IoT devices, yes.
Thank you.
I presume the mics are for the cameras? Okay. I mean, you know, the devices end up being run by humans, so, you know, I would imagine that, you know, you'd associate maybe your cell phone with the person who generally carries it. So I think those would end up going hand in hand, but, you know, I think really we're probably pretty open to collaboration with other people who are working on the same problem. I poke in on the channel for the Identity of Things work group every once in a while, and I see new faces in there. So I presume, you know, if that's something, you know, your organization is interested in collaborating on, I think contact us at probably contact@iota.org, and you know, we'd love to.
You can send it to me and I can route it.
Yeah, him. There. Yeah, that.
I'd say overall when it comes to identity on the blockchain, there's sort of 3 different ways that it comes about. The first way is it's sort of by emergence. So it's kind of like how we handle identity at this point in time. It's largely based on what social media platforms you have. When you go to a website, it says log in with Facebook, right? So this is emergent. This is based on the data that you're contributing to the network. So that kind of grows about naturally. There's a reputation system that's kind of built into it. Another way is through more secure traditional methods, which is kind of like KYC, which is know your customer. So if you go to a bank or an exchange or anything like that, they're going to actually look for bank statements. They're going to look for some record of where you actually live, maybe a copy of your driver's license or something like that. So there could be validators in a system that would go through and validate, like, yes, this ID on the blockchain is actually yours. So that's a second method for identity management. The third way is a little bit more abstracted, where you're not actually, like, the identity of a person isn't actually so much of a concern. So in a network where people have to act truthfully, there can be economic incentives in place where they're incentivized to behave in a certain way. So we talked about proof of stake earlier. So there might be some sort of a behavior that a network needs somebody to contribute. So we were talking about like a decentralized Uber, for example. You could go ahead and script that in so that way the Uber driver has to put a certain amount of tokens into a pool. If they don't drop you off at the right location, or if there's some kind of a dispute, they actually lose their tokens. So there's not as much of a reliability on the reputation as much as there is on the task that actually needs to be completed. So.
Hi, thanks so much for being here. This is really interesting stuff. My question is around funding of innovation. So you talked about how, kind of what I gathered from what you were saying was that some of the value is going to shift away from OEMs as we're engaging more in peer-to-peer transactions. OEMs have huge R&D budgets. They're the one, in a large part, funding some of the innovation around autonomous vehicles. How do you see that shifting, that being funding of innovation?
So when you put yourself in the shoes, you know, like the German industry, of course, is heavily reliant on the automotive industry, right? There are a lot of jobs tied to the automotive industry. In Detroit, it's similar, right, in Japan. And when you think about how the world is shifting now, that mobility becomes very technology-driven with autonomous driving and so on, and new players emerge now, right, with Waymo and other technology companies. Then, of course, there's a big risk that the auto industry faces the same destiny as the media industry did, yeah, where it's hard to make a living as a journalist, yeah, and the OEMs are relegated to basically becoming the Foxconn, yeah, the manufacturer of some vehicles that will become commoditized. They will lose their emotional value, and we diminish car ownership and so on, yeah? And the real monetization then shifts, like we have today on the web, to actually monetizing the time we spend in the car, yeah? So we got to look at ads and stuff like that, right? But the ride is actually subsidized, yeah? So, and the challenge, of course, is now also when you think about a city, you know, cities, of course, they also want data, but they very much rely today on technology companies to help them get access to that data, right? And I think it's not a future that we should be aiming for, yeah? you know, we as citizens should maybe share our data with the city because we care about the traffic in Seattle. Yeah, I just, you know, I work from home when I'm not traveling, so traffic is bad. Yeah, just coming over here, it's not great. Yeah, we need to make sure that traffic flows well, and I'll be happy to share my data in an anonymized way to make the traffic flow better and all that kind of stuff, right? But it shouldn't be any one entity owning and controlling that, yeah? So clearly, I mean, I like, you know, I worked in the shift to the cloud, right? Where you basically move away from selling the software and say, okay, 3 years later, I come back when you need more licenses, yeah? The cloud has changed that. Now you have to operate that software as a service, you know, be efficient at doing it, and you get like small revenue streams, yeah? So the auto industry is facing the same problem now, right? That we have less car ownership. So now we have to actually develop a B2C engagement, yeah? You know, you as a customer will be important in that relationship because otherwise you can shift quickly, right? You just pick another mobility service next time, yeah? So this is a huge transformation, yeah? But I tell these guys, you know, I worked for Microsoft when we tried to take on Google with regards to search and online advertising. And we all know how that ended, despite there was no lack of technical resources or money. So I'm getting kind of worried about if we don't make the playing field fair for everybody, that there will be industries losing and we will all become very dependent on a few players. Yeah? So I think we need to think about how do we democratize data and the future business model so we all benefit from it. Because one thing is also for sure, yeah? You know, when you make yourself too dependent, at some point in time, the things that are free today will cost money and so on, yeah? So it's always how do you get people into a state where they are dependent on you, yeah? So I think we should not, when it comes to the future of data and AI, we should not be dependent on anyone. We should be in control. And that means, you know, for the OEMs, yes, it's going to be a difficult transformation, but that's why they're also very excited about this. Because if you think about a vehicle, it generates lots and lots of data, right? But the question is, will it become a cost or will it be an opportunity to monetize the data? And as it stands today, it's going to be very difficult if one or two companies own the services to actually monetize the data and the other guys have to do all the hard work. Also when it comes to compliance and regulations, right? People always ask me, why is it that certain companies are so innovative and so on? And I say, well, one company is largely unregulated. Yeah? The other company is regulated like a telecommunications firm, right?
Real quick.
One company is a media company that is operating under certain restrictions, right? So likewise, automotive is very regulated, so we need to make sure everybody plays by the same rules, yeah? And distributed ledgers could be one way to do that.
Real quick, we only have 3 minutes left, so we're going to need a little bit faster answers so we can sneak in maybe one or two questions. Please.
Hello, thanks for the talk. That's great. Thank you. So I was wondering, what do you think the response is going to be from these big centralized players when this decentralized technology kind of comes more into the consumer's hands and we actually have the ability to do some of these things that you're talking about?
Cool. Yeah, I think the real brief answer, the deep end game, is they'll likely become big players in that protocol, whatever it might be, but they'll be a peer just like the rest of us. They'll just be one with slightly more resources, so we'll be competing on a very even playing field. Yeah.
Maybe if I can add, you know, if you think about it, today you give away your data for free. But it's not for free. Imagine you owned and controlled your data. Yeah? You have a rich set of data across your different personas, yeah? That you could now actually, if you wish, aggregate, provide in different ways that are attractive to third parties. Yeah? But now they need to come to you to ask you, hey, I'm interested in your data, right? Where today you have given it up as you signed onto the service. So it changes the whole game dramatically.
We'll move on. We have 2 more questions over here. Sorry.
I have a question over the IOTA, right? So you mentioned IOTA scaling very, very well compared with the blockchain, right? So to my understanding, the blockchain you do very heavy computation to the proof of work of this thing, right? So it makes it really, really costly, right? So but at the other side, I'm wondering is it's also a way to make it really hard to hack, to be hacked. So what's the IOTA side to make it really hard to hack?
We have 30 seconds left, so rapid fire answer, please.
The first fundamental assumption is that spectrum and bandwidth is a finite resource that you cannot infinitely exceed, and therefore you can only occupy so much. And instead of trying to occupy a block, you're trying to occupy bandwidth. You're trying to occupy broadcast priority, and we use the consensus logic is really ends up kind of being a swarm-like consensus in IOTA. I'm trying to be brave.
That was brief. I invite you guys to follow up after the fact. Thank you, everyone. If you want to follow up with any of our guests, I think they'll be around for a couple moments longer, so we'll do that. And then we have one 5-second pitch from one of our sponsors.
Sorry, just 5 seconds. If you want to register for the Startup Weekend event, and there's a scan, you can actually scan a QR code, or there's a short link at the bottom. So this is a great opportunity to actually build up your blockchain project and actually meet the blockchain investors at this event. Thank you, everyone.
Thank you, everyone.
Thank you. Yeah, thank you. Great.